people who aren't here. Okay. So the first one is a polar coordinate. And it uses distance and angles to record the position of a point. And they have an x and y just like a regular coordinate does. The only difference is the x value is an actual number, like 2, 1, and then the y is actually a degree. So you have to know where the degrees are on the unit circle. Okay. In a polar coordinate system, a fixed point O is called the pole, but it's the same thing as the origin. So if you hear me say pole, that's the same thing as the origin, the center. And then the polar axis is usually the horizontal ray directed towards the right from the origin. So the polar axis, if it's a horizontal line, that's the same thing as your what on a graph? Horizontal x-axis. Good. So put in parentheses x-axis. Same thing. Polar axis is your x-axis. The location of point P on a polar coordinate system can be identified by the distance away from the pole. And what's the pole? The origin. So the distance away from the origin and the angle. So this is like what a polar coordinate would look like. The R is the first number, so sometimes it'll be like 1. So that means it's 1 unit away from the origin. And the angle will be something like 45 degrees. That's in what quadrant? First, and it'd be like the middle of the first quadrant. Y'all know where 45 degrees is, I hope. Alright, if a ray is drawn from the origin through point P, the distance from origin to point P is the absolute value of R, because you know distance can't be negative. So for example, if you're looking at like point V right here, the distance between the origin and this X value is what? 5. It can't be negative. The distance is always going to be positive. Alright, the measure of the angle formed by OP on the polar axis is theta. Y'all know that's just the same thing as a missing angle, theta. And the angle can be measured in degrees or radians, and we'll have a little bit of both. So this is how we graph them. Super easy. Y'all see these little circles right here that go all the way around? The distance between the origin and the first circle, that's 1. This is 2, 3, 4, 5, and 6. So first of all, find 45 degrees, and that's where? Good, between pi over 6 and pi over 3. Some of them aren't labeled. So this is the angle we're working with, and you just start from the origin and go 2 towards that angle. So for example, you just go 1, 2. That's it. You find 45 degrees between pi over 6 and pi over 3, and then this is the distance from the origin, so you start at the origin and just go 2 out on your angle. And that's point what that we just drew? So make sure you label it. Yeah, the only difference is the negatives are kind of weird, so don't do those yet. Let's do one more together. 270 is where on this? So it's the same thing as 3 what? 3 pi over 2. So it's going to be on this line, and we just go how many spots from the origin? In that direction. 1, 2, 3, 4. And this is point Q. So it's pretty simple. Now let's look at a negative one just so we can know what we're doing. For example, this one has a negative angle, so it's going to start at 0 and go which direction? Down, or clockwise, okay? So negative pi over 3 is the same thing as subtracting. What is pi over 3, by the way? 60. It's the same thing as subtracting 180 from 60. So what's, not 3. 360 minus 180, which is, what am I saying? 360 minus 60, which is what? 360 minus 60? Thank you. So where's 300 degrees at? This one?
In between 5 pi over 3 and 11 pi. The one before that.
This one?
No.
This one?
Yeah.
I know that looks confusing. These are actually not angles that we've studied. Y'all can mark these out. But it is right beside 270. You're correct. So you can mark out these. We're not going to use these right here. So this is actually 300 degrees. Same thing as negative pi over 3. So we go to this angle and go how many from the origin?
5.
3. That's the x value in that direction. 1, 2, 3. And that was point what?
U.
Very good. Now let's look at one more where we have like a negative x value. So that's negative 5 right here. 0 degrees is just this part right here. Everybody knows that, right? So if it's negative 5, you're still going to stay on this line where 0 degrees is, except you'll go in the negative direction. So instead of 5 to the right, you go 5 to the left. 1, 2, 3, 4, 5. And that is point B right here. Alright, I want you to try to graph the rest of these on your own. I'm going to put a check mark by the ones we have done. And I want you to take a minute and graph these on your own. If there's one you don't know how to do, skip it, and because we're going to go over these, okay? You're here Friday, right? So I gave you all the notes and stuff for the next 2 weeks. So we are working on 7.30 notes.
No, you're following that. You're going the normal direction and you're following down.
Oh, so basically,
Yep. 180 is here, right?
Is it?
So you go 1, 2, 3.
So
if it's a negative, then you go that direction. If it's a negative, then you go the opposite direction.
But what
So
you did
look at this one. What would you do with that one?
I would go left. I would go 150 degrees up there that way.
So where's 150? Where's 150 then? Okay. So now because it's negative 2, if it was this one here, maybe it's the opposite way. And this one, put that negative right here.
This way.
So this here, so if it was here, and that one, you're going to go on this one.
So after I'm coming over here, okay,
Yes.
still on this side.
Okay. Because you're coming opposite direction.
Now this is hot.
But this negative means you have to come this way.
This one.
Yeah.
So how do I do that? Like, which way do I make it?
So this would be negative 90. This is negative 180. So negative 135. Here's the middle, right?
Give me about one more minute, then I'm going to show you where the points should
So right here.
And how many away from the origin?
Two.
Yep. That's the point. W, right?
Yeah.
There it is. Yep.
This is confusing.
You'll say that and then make 100 on the test. Mm-hmm. Alright, let's take a look. Alright, I'm going to zoom in so you can check your points. Let me know if there's one I need to go over that you did not get. A, B, C, and D are all in the same, they were all the same point. Is there one I need to review?
Wait, why was B the same?
Let's look at that one. So B was negative 4, 5 pi over 4. So we know 5 pi over 4 is the same thing as what? Oh, okay. Just a second.
Could you show C real quick?
Yeah, C and
So
B.
you got C because, wait, where's because the negative 4 and negative 3 are 4.
Do I need to sign anything?
No, I just had to check them off.
Okay. Alright, let's look at 5 pi over 4. And Kels, tell me what 5 pi over 4 is.
I didn't know if you wanted like the actual.
Yeah. 225. So that's, you know, the 225 same thing as 45, like it's going to be in the middle of something. It is in quad what? Good. So this is 225 right here. I'm going to kind of put a dotted line. And then negative 4 means that instead of going towards 225, anytime it's negative, you go away from it. So that's why this is 225, but instead of going towards it, you go 4 away. 1, 2, 3, 4. That's why it's right there.
He said that if it's negative, it's
Still the distance between the origin and that still 4. Yeah, whether it's here or here.
With 270, but it makes sense because otherwise not.
Gotcha. Any other ones y'all needed to see? Alright, how y'all feel about graphing polar chords? Which one? R. Let's look at that one. R and Y. Alright, I'll underline them. Alright, R is 180, so you know that's right here, correct? So you go 3 towards 180. So I just go out 1, 2, oops, should be right there. I just went 1 extra. And you said Y? Somebody said Y? Alright, negative 7 pi over 6. What is that the same thing as? How do I know, or how can I find out if I don't know? Negative 7 pi over 6. If I didn't know, guys, if you don't know, just hit negative 7 times what? Divided by 6. And it's negative 210. So all you have to do to find out the positive angle is do 360 minus 210. So this is the same thing, or same place as 150. Everybody good with that?
But doesn't all negatives just reflect reflect over the x-axis.
Yep. So if you can do it that way, do it that way. It's quicker. So 150 is the same thing as what? Or where would that be at? Yes, 5 pi over 6, which is right here. And so you would go -3 away from 5 pi over 6, which would be, let me not get tangled, 1, 2, 3, right here. So anytime it's negative, you're going away from that angle, the opposite direction. Does that make sense? Y'all have any questions about graphing them? Remember you have a quiz on it Thursday. Alright, and a checkpoint on it Wednesday. Okay, next thing we're going to do is convert polar coordinates to regular XY coordinates. So polar coordinates, what we just graphed, now we're going to convert it to XY and then back. So if it's from polar to regular, to find the X value, you just do R, and then think about on a unit circle, what is your X value? It's dealing with what? Cosine. So it'd be R cosine theta, and then your Y is always going to be R sine theta. That's going from polar to rectangular. That's how you find those values. Alright, now from rectangular to polar, remember we talked about R, and these was the what? Remember Kelts was just talking about this. R is the same thing as the distance between the origin and that point. So what do we do to find the distance between two things? 2 points? Distance formula. Good, which is the square root of x squared plus y squared. So that's how we find R. Square root of x squared plus y squared. It's really x2 minus x1 squared plus y2 minus y1 squared.
Yeah.
But with this, you know you only have one x value. X my value. And then theta, to find that angle that we need, it's just going to be tangent. You're going to take tangent theta, which is the same thing as y over x. Sine over cosine. Remember, sine is your x, y, cosine is your x. Alright, so let's start with going from polar to rectangular. So this is what we're going to use. No, you will not have these on your quiz on Thursday. You'll just have to memorize it. So the first one to find x is going to be R cosine theta. What's our R here? 2. And it's going to be cosine of 3 pi over 2. And what is 3 pi over 2? You sure? Yes. Y'all know y'all don't have to guess, right? You can just type it in 3 times 180 divided by 2. So it's 270. So cosine of 270, I'm going to mark that out. And then y is going to be 2 times what? We're not there yet. Your y value is always going to have what involved? Sine of 270. So this is why we have to keep having tricky Tuesdays, tricky Thursdays, because you have to know what cosine and sine of 270 is. We're having tricky Thursday this week because we're not going to be here Tuesday. Alright, so 270 is right here. What's the coordinate point for this? 0, negative 1. Very good. So cosine of 270 is going to be 0. It's always your x value. So what's 2 times 0? Good. And your y value is always going to be sine. So it's going to be 2 times negative 1, which is what? Very good. So this was the polar coordinate. This is your rectangular coordinate, or sometimes you'll hear it called Cartesian. Repeat what part? This is the polar, because it says go from polar to rectangular. This is your rectangular. Alright. Next one together, and then I'll let you do 3 on your own. Alright, to set up x, it would be x equals cosine. Good. Next one would be y equals negative 3 sine of 120. Good. What's the reference angle for 120? 60. Very good. So cosine of 60 is going to be what? 1/2. Very good. But this is in quad what? So cosine is going to be what? So this is going to be x equals negative 3 times
Oh, 1/2.
negative 1/2. Very good. Your y value is going to be negative 3. What is sine of 120?
Square root 3 over 2.
Good. It's going to be positive or negative?
Negative. No, positive.
Because it's in quad what?
2.
Very good. So your x value is going to be negative 3 times negative 1/2. That's going to be what? Negative? It's going to be what? Positive 3 over 2. This next one's going to be negative 3 root 3 over 2. Remember that when you're dealing with finding these trig values, do not give them to me as a decimal.
How did you get that 3 square root of 3 over 2?
Because you have to multiply negative 3 times square root of 3 over 2.
That's crazy.
Alright, try 3 on your own. Let me know if you need some help. Which side is cosine? Good, so be good, 1 and then find sine of 60. So that's for your y value. So y equals no. You said negative. Now let's do the same thing. 60 is which one? So which side is sine? So it would be square root of 30 over 2. It's always over 2. Now what? Alright, let's go over these. Alright, we know the setup. It's going to be x equals negative 8 cosine of pi over 3, which is the same thing as what? 60. And we have negative 8 sine of 60. So what is cosine of 60? 1/2. Good. What about
Y equals
sine of 60?
square root of 3 over 2.
Very good. So when we multiply these,
I got 4.
should be what? Negative 4. Next one should be negative 4 root 3. Very good. Y'all have any questions about that?
What if I left it negative 8 square root of 3 over 2?
Negative what?
What if I left it negative 8 square root of 3 over 2?
I'd count off a point just because you didn't simplify. It wouldn't be totally wrong though. Alright, now let's go backwards. So we have a regular rectangular coordinate. How do you know? Because there's no angle involved or anything. So now we're going to turn this into a polar coordinate, which means it's going to look like r and then some angle at the end. Alright, so how do we find r? Remember, it's the distance, so we have to use what? distance formula, which would be the square root of, which is going to be just 1, right? And what about square root of 3 squared? What's that going to be? So it would be r equals square root of 4. So our r is what? Yes. Now we just have to figure out our angle. And we're going to use tan for that. And tan is blank over blank. Sine over cosine, so it's going to be our y value over our x value. Good, so it'd be tan. And what are we looking for again? The angle, correct? Y'all remember what button to use in your calculator if we're looking for an angle? The inverse. Very good. Tan inverse, excuse me. And this is going to be square root of 3 over negative 1. So I want you to type in your calculator tan inverse. And this is the same thing as what right here? Negative root 3. Alright, type that in and tell me what you get. Negative 60. Okay. That doesn't mean that's what tan is. Can I show you how to type in the calculator? You type in second tan negative root 3. You can't type you can't type the negative inside the square root. Is that what you did? There we go. Did you type it in just like this? Let me check if your calculator's in the right mode. Oh, you actually typed a subtraction sign instead of the negative sign. People do that a lot. Okay. So that doesn't mean that's what the angle is, but it gives us an idea of what it could be. Okay. Let's look back at our point. We notice that cosine is what? And sine is positive. That tells us it's in what quadrant? Yeah. No. If cosine is negative and sine is positive, what quadrant? 2. Quadrant 2. All students take calculus, so it's in quad 2. Now think about what angle in quadrant 2 has a reference angle of 60. Which is what? What degree is that? Not quite. 120. How can we check this? To find the reference angle for something in quad 2, don't we do 180 minus that angle? Right? So what do we have to subtract? Or let's set it up like an equation. 180 minus theta equals 60. So how do we get 120 right here? Subtract 180. What's 60 minus 180? So negative theta equals negative 120. So theta is 120. Is everybody with me? I'm going to go over it one more time. So when we type this in, we got negative 60. That just tells us our reference angle. That 60 is the reference angle. Okay? You have to look back at the point to see what quadrant it's in. If cosine is negative and sine is positive, all students take calculus. That's going to be in quad 2. So how do I find the reference angle for something in quad 2? That's 180 minus whatever angle it is. I set it equal to 60 because that was our reference angle. Then solve for theta. Our final answer is 2. That was R, comma 120. Or if you want to put it in radians, you can. Everybody good with that one? Let's try some more. Alright, number 5. We'll start by finding R. Tell me how to set that up. Which is plus 0 squared, which is just 0. So R is what? 2. Very good. Let me zoom in. Alright, now we're going to type in our calculator tan inverse of what over what? 0 over, which is just good. So type that in. Tan inverse of 0. Actually, we didn't have to do that on this one. I'll explain why. Yes. But think about this coordinate point right here. All you have to do is graph this like on a regular plane. That would be right here, correct? What angle is that? Yes. So So that's our angle. To 180. So in short, you don't have to type this in your...
Teachers and students, please pardon the interruption. I just wanted to make another couple of announcements. This will be the last opportunity that I will have to do that before we dismiss at 12:30 today. But I wanted to, for this one's for madrigals and women's choir. Okay, if you are involved in that, all madrigals and women's choir are to meet in the choir room Wednesday morning, dressed in concert attire no later than 7:40 a.m. to go to the state choral performance assessment. Okay, just remember that. We won't be making announcements tomorrow because of all the different activities and the testing that will be taking place, so I wanted to go ahead and remind them of that today. Also, just wanted to remind everyone when we dismiss at 12:30 p.m. today due to weather, to please, students, everyone, please, we will be closing the school soon after that, after we get everything cleared. The campus will be cleared, so I'm just reminding everyone to please go home and be safe and be weather aware this afternoon. I want everyone to watch for that and to just be very, very careful and to be weather aware and to watch that and be home and in a safe place this afternoon. Juniors, want to just remind you about tomorrow. Make sure you get plenty of rest tonight and eat well and rest up for tomorrow because it is a big day for you guys with the ACT. You've been working very hard, prepping very hard in class, in all of our ACT prep opportunities that we've had. You've done a great job of that, and we are excited about the success that you're going to have in your performance for tomorrow on the ACT. You're going to do a great job. You're going to knock it out of the park, and we are excited about tomorrow for you and for all of us and for our teachers and everyone who's worked very hard to get you to this point. So we're excited, and we're looking forward to a lot of success tomorrow. Just get plenty of rest. Be ready to come in tomorrow and do a great job. Remember also for seniors, if you have any questions in regards to assignments, make sure you touch base with your teachers before 12:30 today, before you dismiss. Make sure you have everything. If you are taking part in the day and you won't be here tomorrow, if you are coming in tomorrow, just know that we will be here and we will have classrooms and labs available for our seniors to work on either e-assignments or to participate in their pre-assigned AP activities or do the college and career readiness indicator work with their academy teachers. You should have already spoken with or talked with your academy teachers about those activities. Sophomores, remember 8, 10 after 8 in the morning. Be in the cafeteria ready to go to load the buses for the ASVAB testing. And of course, freshmen, you should have your rosters or you should have your information about which room that you will be assigned to in the morning. So please go to your testing room and your prep room, your ACT prep room in the morning for that. So again, everyone, have a great afternoon. When we dismiss at 12:30 today, we'll be ringing the bell in just a couple of minutes to go to our lunch period. Then from lunch, we will go to fifth period, and then we will dismiss from fifth period at 12:30 to go home today. So everyone have a great afternoon, have a safe afternoon,
Alright, just one thing I want to point out. You don't have to get your notes back out, but if it has a 0 right here, you do not have to type in tan inverse. You can just draw it on a coordinate point and see where that degree is, okay? Just any of them. You don't have to type it out. You can just draw it. 0.5 can be here, C-nut's going to be 0, or excuse me, 0.5's here, C-nut's 9. So anytime it has just 1 0, you can just draw it. I'll show you. Hold on.